Now let's take up here question number 54. It states that the domain of this function, which is square root of greatest integer function of x minus 4 whole upon mod of x minus 3, where the symbol represents the greatest integer function is. So basically you need to figure out the domain of this given function. As you can observe here, we are talking about square root of this function. That clearly means in this case you will definitely have square of greatest integer function of x minus 4 whole upon mod of x minus 3 as greater than or equal to 0. Now this means we'll have here two cases. In the first case, we will be considering that square of greatest integer function of x minus 4 will be greater than or equal to 0. Moreover, mod of x minus 3 will be also greater than 0. So this is the first case, and the second case, in this we will have square of greatest integer function of x minus 4 less than or equal to 0 and mod of x minus 3 less than 0 as well. So let us consider this first case. According to this condition, you are going to obtain here that greatest integer function of x is greater than or equal to 2, or it will have greatest integer function of x less than or equal to minus 2. Now in this case, this will come to a result that x is greater than or equal to 2 or x is less than minus 1. Now this is the result obtained, and when you will be considering that mod of x minus 3 is greater than 0, through that you will obtain here that x is greater than 3 or x is less than minus 3. Taking this case into consideration, if we draw here the number line, then let's draw next the number line and see what we obtain. Here on drawing the number line, you will put here the points, that is minus 1, minus 3, 2 and 3. On plotting these points on the number line, you will find firstly I have here x greater than or equal to 2. So I will be considering here x greater than or equal to 2, it will consider this range. For x less than minus 1, you will consider here this range. Now taking up the next case, that x is greater than 3, so we will consider this range, while here x is less than minus 3. So here we will consider this range. You will find that this is the common range in both of these. Now this common range means here we are talking about the values from minus infinity to minus 3 or the values from 3 to infinity. Now this is obtained through the first case. Now let's consider our second case. In the second case, you can observe here basically we are talking about square of greatest integer function of x minus 4 less than or equal to 0. Through this, you will obtain the result that this greatest integer function of x is greater than or equal to minus 2 less than or equal to 2. And this results here that we have x greater than or equal to minus 2, x is less than 3, and through this inequality that mod of x minus 3 is less than 0, we obtain that x is greater than minus 3 and x is less than 3. If I plot this on the number line, here I'll be considering the points, that is minus 2, minus 3 and I have here 3 also. If I take this into consideration, you can see for the first one I have to consider this range from minus 2 to 3 where minus 2 is included. Next from minus 3 to 3. From minus 3 to 3 this is included. So this is the common range here, and common range represents from minus 2 to 3 where minus 2 is included, 3 is excluded. So if we consider these both cases, we get the required domain of the given function, and that comes out to be from minus infinity to minus 3 union I have here minus 2 to 3 union I have here 3 to infinity. So this is the required domain of the given square root function. So I hope you have very well understood this question. So coming back to the given options provided, here we are talking about the domain of this given function, which is clearly found here in option number 2. So you can definitely mark your answer as option 2. And You can write here answer for question number 54 is option 2. I hope it's clear to you. Let's take up our next question. Here I have question number 55, which states that the number of points of intersection of the curve mod of y equal to mod of log of mod x with the curve mod of y minus 2 equal to mod of x is out of these options. So very first let's trace the curve log of mod x. So on the Cartesian plane, when you trace this curve log of mod x, but here we need mod over log of mod x also as well as y. You will find that this portion will come in the upper half and this portion will completely replicate in the lower half, and you will get a graph like this. On getting this graph, next we need to figure out this curve, that is mod of y minus 2 equal to mod of x. If I just plot the straight line, that is y minus 2 equal to x, I'll get a straight line like this. Now taking mod over x as well as y function, I get here this as the graph. Now these are the two graphs traced over here in this plane. Now let's obtain the required points of intersection. So here I have this point 1, 2, 3 and 4 such point on this side as well as 1, 2, 3 and 4 such points here. That means total 8 points are there under consideration. So the required point of intersection is 8. So out of these options, you can clearly say that the correct answer is option number 4. You can mark here the required answer is option 4. I hope it is clear. Now let's take up our next question. Here I have question number 56. It states that the range of this function, which is f of x, equal to log of twice of sine square x minus twice of sine x plus 1, where base is 1 by 2, is out of these options. So let's obtain the required range. So very first we are considering this given function, which is log of twice sine square x minus 2 sine x plus 1. So the range depends on this value. Let's try to figure it out. If I am considering that y is equal to twice sine square x minus 2 sine x plus 1. Now in this case, if you want to simplify it, you can easily take 2 common from the first 2 terms. After that, on completing the identity, here you will obtain 2 sine x minus 1 by 2 whole square. On completing this identity, you have added here minus 1 upon 4 and plus 1 upon 4. So minus 1 upon 4 will go out of this bracket. 2 into minus 1 upon 4 results here minus 1 upon 2 plus 1. This whole constant term simplifies to the value plus 1 upon 2. So this is the value of y. Now in order to obtain the range, you need here the minimum and the maximum possible value of y. That totally depends on this term, that is sine x minus 1 upon 2 whole square. For that, if I consider that in this case this whole term becomes equal to 0, that is possible when sine x is equal to 1 by 2, and that is quite possible because sine x has the value equal to 1 upon 2. So when sine x becomes equal to 1 upon 2, this whole term becomes 0. 0 into 2 becomes 0 plus 1 by 2. The minimum possible value is 1 upon 2. The next possible case is to obtain the maximum value of this. Now that also depends on this quantity. When the value of sine x will be minus 1, then you will obtain here minus 3 by 2 square, that is 9 by 4. Twice of that gives me 9 by 2. 9 by 2 plus 1 by 2 results the maximum possible value as 5. So y has maximum possible value as 5, minimum as 1 by 2. When you go back to the question, here f of x is equal to log of y with base 1 by 2, and we have obtained the maximum and minimum possible value of y as 5 and 1 by 2. Taking that case into consideration, I get here that f of x varies from log of 1 by 2 with base half, because maximum value will be this, and the minimum value will be log of 5 with base 1 by 2. This reduces to the value 1. That means the range of f of x is from log of 5 with base 1 by 2 to 1. And out of these options, you can clearly figure out the correct answer for this range is given in option number 2. That is log of 5 with base 1 by 2 to 1. Both are included. So out of this, I can clearly mark the correct answer as option number 2. So the correct answer is here option 2. I hope it is clear to you. Now let's take up our next question.